In this video, we'll be discussing sterilization and disinfection, two important safety topics for the research laboratory. We'll also be discussing how to apply them to our work in the laboratory. First, we're going to go over some important definitions. Disinfection is defined as the process of destroying unwanted microorganisms. Sterilization is an absolute form of disinfection where we've destroyed all unwanted microorganisms on a surface or an object. These concepts are sometimes confused with antisepsis, or the process of removing microorganisms from living tissue, as well as aseptic technique, the practice of working in a clean environment and minimizing contamination to your work. There are many different ways in which we can destroy unwanted microorganisms, including heat, chemical disinfectants, as well as radiation. Today, we'll be discussing a number of those. First, we'll be discussing chemical disinfectants and sterilants. The most important thing in using these kinds of agents is that their efficacy is based on the contact time to the material it's being applied to, as well as the concentration that we're using. In general, the higher the concentration and the longer the contact time, the more effective the materials will be. The most common disinfectant and sterilant employed in the research laboratory is household bleach, or sodium hypochlorite. It's a great choice because it's cheap, easy to use, and widely available. Household bleach is not only a great disinfectant and sterilant, but can also be used to break down recombinant and synthetic DNA. This makes it perfect for the research laboratory. If you create a 2% volume per volume solution, it's great for cleaning up general materials in the laboratory. However, at a 10% volume per volume solution, it can be utilized to destroy both biohazardous materials and recombinant DNA with a sufficient contact time, usually around 20 to 30 minutes. However, bleach does have its downsides. Sodium hypochlorite is a strong oxidizing agent. This makes it perfect for our work in the laboratory as a disinfectant, but it also means that it can corrode and destroy the surfaces that it's being applied to. Additionally, it breaks down very quickly over time. This means that once a bleach solution is made, it stops being effective within 24 and 48 hours. If bleach and alcohol aren't appropriate for the work taking place in your laboratory, there are a number of commercially available options that could be right for you. Please make sure to consider the shelf stability that you're looking for, the type of effectiveness or what kind of organisms you're trying to destroy, and the kinds of surfaces that will come in contact with the sterilants and disinfectants. If you have some questions or need some help picking the right kind of disinfectant or sterilant for your lab, feel free to contact Environmental Health and Safety. Some applications inside of the research laboratory call for physical disinfection as opposed to a chemical one. The most common form of physical disinfection is wet heat, or an autoclave. An autoclave uses steam at an elevated temperature and pressure to sterilize materials inside of it. In general, in order for us to accomplish sterilization inside of the autoclave, we need to apply 121 degrees Celsius at 15 psi for a very minimum of 30 minutes. A less common form of physical disinfection is the use of UV radiation. UV radiation is not recommended to be relied upon as a sole form of sterilization or disinfection because it has the potential to be blocked by shadows. Now that we've covered physical and chemical disinfection, you might be wondering, when's the right time to use it? Chemical disinfectants are perfect for cleaning surfaces. This makes them ideal for cleaning up a spill or treating liquid waste. Physical disinfection, or using an autoclave, is great for preparing reagents as well as getting rid of solid waste generated in the laboratory. Again, if you have any questions regarding physical or chemical disinfection or other methods not covered in this video, please feel free to contact Rice University Environmental Health and Safety or consult your biosafety manual.